Hey all! So today I want to show you a method of solving a system of linear equations. The first thing you should know is that a system is two or more equations. If it was one, it would not be a system. So let's look at this system of linear equations. So if I have 12x plus 5y, and that equals 7, that's one linear equation. So my second linear equation is going to be negative 4x plus 10y equals negative 7. Okay, so as I'm looking at this system of linear equations, I have to think to myself, which method would be the best to use? Would it be graphically? Would it be substitution? Or would it be the elimination method? The answer is the elimination method because we can see that this is written in standard form. All we have to do is figure out what we have to do to one or both of the equations in order to eliminate one of the variables. So as I look closely, I can either manipulate the first equation to eliminate the y's, right? If I eliminate the first equation, I want to get this here to either a 10y or a negative 10y because that will help me to eliminate. Right? Or I can manipulate the second equation and I can get this negative 4x to either a negative 12x or a positive 12x to eliminate the x's. So I'm going to go ahead and eliminate the y's. So in order to eliminate the y's, I want this 5y to become a 10y. So, well, a 10 or a negative 10. I'm going to say, let's make it a negative 10. So I know 5 times 2 is 10. So 5 times negative 2 is negative 10. All right, so this is how I do this. This negative 2 gets distributed to every term of the equation. So negative 2 times 12 is negative 24x. Negative 2 times 5 is negative 10y. And negative 2 times 7 is negative 14. So I've just manipulated that first equation so that I can add up these two equations, and that will eliminate my y's because 10 plus negative 10 is 0. Okay, so my y's are eliminated. Now let's look at my x's. Negative 4x plus negative 24x, so that's a negative 28x. And then that equals negative 7 plus negative 14, which is a negative 21. So we get negative 28x equals negative 21. So I need to solve for x now. In order to solve for x, I need to isolate the x. So because negative 28 is multiplying x, I am going to divide by negative 28. And what I do to one side, I do to the other side. Now, negative 21 divided by negative 28 is a positive 0.75, or 3 over 4. So my x value is 3/4. Now that I have an x value, I can go back up to my original two equations, and in any of them, I can substitute in a positive 3 over 4 and for x in order to solve for y. So it really doesn't matter which one I choose. It just matters that I choose one. So I'm going to choose the 12x plus 5y equals 7. And like I said, anywhere I see an x, it's now going to be replaced with a 3 over 4. So 12 times 3 is 36. 36 divided by 4 is 9. So 3/4 of 12 is 9. So 9 plus 5y equals 7. Now, to isolate the variable y, I'm first going to have to move the 9 to the other side through addition or subtraction. Well, in this case, it's going to be subtraction because it's positive on the left side, so to get rid of it, I need to subtract it. 7 minus 9 is negative 2. And then, to finally get y by itself, I'm going to divide by the coefficient, which is 5, and we get y is equal to negative 2 over 5. So our solution is 3 over 4, comma, negative 2 over 5, or 0.75, comma, negative 0.4. Now I could trust it or I can check it, and I always choose to check it. So to check it, I'm going to go back up here, and the equation that I did not use, I'm going to now use. So the negative 4x plus 10y equals negative 7. Okay, so I'm going to use that. So negative 4x plus 10y equals negative 7. And I'm just going to plug in my x with a 3/4, and for y, I'm going to do negative 2/5. So this is what I get. 4 times 3/4 plus 10 times negative 2/5. That should equal negative 7. And when I do this, if I do end up getting a negative 7 on the left side, then I know that it is, in fact, a solution to both of my equations. Well, 3/4 of negative 4 is negative 3. And 10 times negative 2/5 is a